Hey everybody, Vedika here, and welcome back to the channel. Today, we're going to be taking a deep dive into the fascinating world of encoders. These little components are the unsung heroes of the digital world, quietly doing their job in everything from robots to your computer mouse. So, whether you're a seasoned pro or just starting out, stick around, because we're going to cover everything you need to know about encoders, from the basic theory to some really cool real-world applications. Let's get started. Okay, so before we get into the nitty-gritty, let's answer the most basic question. What the heck is an encoder? In the simplest terms, an encoder is like a translator for your electronics. It takes real-world information, like the position of a knob or the speed of a motor, and converts it into a digital language that your circuits can understand. Think of it like this. You've got this awesome idea for a robot that can dance, right? But how do you tell the robot how to move its arms and legs? That's where encoders come in. They act as the communication link between your robot's brain, the microcontroller, and its limbs, translating those dance moves into a language the robot can groove to. Pretty cool, right? Now, just like there are different languages for us humans, there are different types of encoders in the digital world. Each type of encoder has its own unique way of translating information, much like how different languages have their own grammar and vocabulary. Understanding these encoders is crucial for anyone working with digital systems, as they play a vital role in how data is processed and interpreted. There are several types of encoders, each designed to meet specific needs and applications. Let's dive into the fascinating world of encoders and explore their unique characteristics and uses. First, let's talk about the most common type, the binary encoder. These encoders are all about simplicity and efficiency. They use a series of ones and zeros, the fundamental building blocks of digital systems, to represent different positions or values. Imagine a light switch, but instead of just on or off, you have multiple positions, each with a unique binary code. This is essentially how a binary encoder works. It's like having a language with only 2 letters, but with those 2 letters, you can create an infinite number of combinations and meanings. Binary encoders are widely used in digital electronics because they are straightforward and reliable. Next up, we have priority encoders, which are like the overachievers of the encoder world. They can handle multiple inputs at once and will always prioritize the highest input signal. Think of it like a group project where everyone's contributing, but the priority encoder makes sure the best ideas rise to the top. This makes them incredibly useful in situations where multiple signals are being received simultaneously, and it's crucial to determine which signal is the most important. For example, in a computer system, a priority encoder can help manage interrupts by ensuring that the most critical tasks are addressed first. And then there are decimal encoders, which are like the translators for the metric system. They convert those binary signals into easy-to-read decimal values, making them perfect for applications where you need to display numbers directly, like on a digital readout. Decimal encoders are essential in devices where human interaction is required, as they provide a more intuitive way to understand and interpret data. Imagine trying to read a digital clock that only displayed binary numbers. It would be quite challenging. Decimal encoders bridge this gap by translating the binary information into a format that is easily understood by humans. Another interesting type of encoder is the gray code encoder. Unlike binary encoders, gray code encoders are designed to minimize errors during the transition between values. In binary encoding, changing from one value to another can result in multiple bits changing at once, which increases the risk of errors. Gray code encoders address this issue by ensuring that only one bit changes at a time, making them ideal for applications where precision and accuracy are critical, such as in rotary encoders used for measuring angles and positions. Speaking of rotary encoders, these devices are used to convert the angular position of a shaft or axle to an analog or digital code. They are commonly used in industrial controls, robotics, and even in some consumer electronics. Rotary encoders can be either absolute or incremental. Absolute encoders provide a unique code for each position, ensuring that the exact position is always known, even after a power loss. Incremental encoders, on the other hand, provide information about the motion of the shaft, such as speed and direction, but require a reference point to determine the absolute position. Lastly, let's not forget about optical encoders. These encoders use light to detect the position of an object. They consist of a light source, a photodetector, and a code disk. As the code disk rotates, it interrupts the light beam, and the photodetector generates a corresponding electrical signal. Optical encoders are known for their high resolution and accuracy, making them ideal for applications that require precise measurements, such as in medical devices and scientific instruments. In conclusion, understanding the different types of encoders and their specific applications is essential for anyone working with digital systems. Each type of encoder has its own strengths and ideal use cases, and choosing the right one can make a significant difference in the performance and reliability of a system. Whether it's the simplicity of binary encoders, the prioritization capabilities of priority encoders, the readability of decimal encoders, the error minimization of gray code encoders, the precision of rotary encoders, or the accuracy of optical encoders, each type plays a crucial role in the world of digital technology. Alright, so we've talked theory, but where do we actually see encoders in action? Well, the answer is pretty much everywhere. Take robotics, for example. Encoders are essential for precise motion control. They tell the robot's motors exactly how far to turn and at what speed, allowing for those smooth, coordinated movements. Then there's automation, where encoders play a crucial role in everything from conveyor belts to industrial robots, ensuring that things move with accuracy and efficiency. But encoders aren't just for heavy industry. You'll find them in everyday devices, too. Ever used a computer mouse with a scroll wheel? That's an encoder at work, translating the rotation of the wheel into scrolling action on your screen. Even your car's anti-lock braking system relies on encoders to monitor wheel speed and prevent those scary skids. Okay, time to get our hands dirty and see how encoders actually work in a circuit. Encoders are fascinating components that convert motion into electrical signals, and they are used in a variety of applications, from robotics to consumer electronics. Now don't worry, we're not going to go full-on electrical engineer here, but understanding the basics of how to connect and use an encoder is super helpful, especially if you're into DIY electronics. Whether you're building a robot, a smart home device, or just tinkering for fun, knowing how to use an encoder can open up a world of possibilities. For this demo, let's say we want to build a simple volume control using a rotary encoder. A rotary encoder is a type of position sensor that can measure the rotation angle and direction. It's commonly used in devices like digital volume knobs, where precise control is needed. We'll connect the encoder to a microcontroller, which will read the encoder's output and adjust the volume accordingly. The microcontroller acts as the brain of our project, interpreting the signals from the encoder and converting them into actions. Now, the exact wiring will depend on the specific encoder and microcontroller you're using, but the general principle is the same. You'll typically connect the encoder's output pins to the input pins of the microcontroller, and you'll need to power both the encoder and the microcontroller. As you turn the encoder knob, it generates pulses that are sent to the microcontroller. These pulses are essentially electrical signals that represent the movement of the knob. The faster you turn the knob, the more pulses are generated. The microcontroller then interprets these pulses to determine the direction and amount of rotation, which it then uses to adjust the volume output. It does this by counting the pulses and determining whether they are increasing or decreasing, which corresponds to turning the volume up or down. It's like magic, but with electronics. By understanding how encoders work and how to integrate them into your projects, you can create more interactive and responsive devices. So, go ahead and experiment with different types of encoders and microcontrollers and see what amazing projects you can come up with. Happy tinkering! Alright, now that you're well on your way to becoming an encoder expert, here are a few bonus tips and tricks to really up your game. These insights will help you refine your skills and make more informed decisions in your projects. First off, when choosing an encoder for your project, always consider the resolution you need. The resolution of an encoder determines how finely it can measure position, speed, or other parameters. The higher the resolution, the more precise your measurements will be. This is particularly important in applications where accuracy is critical, such as robotics or precision engineering. Think of it like choosing a camera. More megapixels mean sharper images. Similarly, a higher resolution encoder provides more detailed feedback, which can be crucial for fine-tuning your system's performance. Secondly, don't be afraid to experiment with different types of encoders. There are many types available, including optical, magnetic, and capacitive encoders, each with its own set of characteristics. Each type has its own quirks and advantages, so playing around with them will give you a better feel for which one is best suited for your particular project. For instance, optical encoders are known for their high precision, while magnetic encoders are more robust in harsh environments. And finally, remember that encoders are just one piece of the puzzle. They work in conjunction with other components to create a fully functional system. To truly master them, you need to understand how they interact with other components in your circuit, like microcontrollers and sensors. This holistic understanding will enable you to design more efficient and reliable systems. So, keep experimenting, keep learning, and most importantly, have fun with it. The world of electronics is vast and full of opportunities for innovation. The more you explore, the more you'll discover new ways to push the boundaries of what's possible. So there you have it, guys. That's the world of encoders in a nutshell. Hopefully, you found this video helpful and maybe even a little bit inspiring. If you did, be sure to give it a big thumbs up and subscribe to the channel for more awesome tech content. And as always, if you have any questions or suggestions for future videos, drop them in the comments below. Until next time, keep on learning, keep on building, and I'll catch you in the next one.